Let us take a look for a moment at the magnificent power of computers and how we can utilize them in critical path planning. Computers have a simply fantastic ability to do things that humans are particularly weak at. They have the ability to remember a virtually unlimited amount of detail. They follow rules they are given accurately and without question. They are incredibly fast and accurate with calculations. They can create graphics accurately in an instant. Of course, there are things that computers cannot do. They have some severe limitations. Computers know absolutely nothing about maintenance outages. Computers know absolutely nothing about your industry. Computers know absolutely nothing about your objective for your outage. Computers know absolutely nothing about the critical work you want to plan. And because of that, computers cannot identify your essential work scope and activity list. They cannot estimate your task durations or identify the resources you require. And of course, they absolutely cannot sequence your activities for you. But you can. Let us take a look at professional project management software available. For this course, we have chosen Microsoft Project as the package of choice. Other software that we very often use is Primavera. Both are built on the critical path method, exactly as taught in this course. Microsoft Project is extremely powerful, while Primavera is even more powerful. Because of that, Microsoft Project is a little simpler to use, while Primavera is substantially more complex. Microsoft Project is relatively inexpensive, while Primavera is slightly more expensive. We found amongst our clients that most people already have a copy of Microsoft Project, while far fewer have a copy of Primavera. Microsoft Project uses the MPP file format. Primavera opens the MPP file format anyway. So we use Microsoft Project because if you cannot master these techniques with Microsoft Project, you will never master them with Primavera. After all, this course is a course in planning and scheduling maintenance outages. It's not a software training course, and either of these programs are professional software packages that would do the job just fine. In this lesson, we are going to explore a simple demonstration of the use of Microsoft Project. Let's go back to our simple example we had in the earlier lessons. Remember, we started off with activity A, which could begin immediately. Then as soon as activity A was complete, we could do activity B, C, and D. And as soon as D was complete, we could do activity E. But we couldn't do F until B and C were both complete. But as soon as E and F were complete, we were at the end of our project. Then we added the time to the activities. Having done that, we were in a position where we could move from the world of logic into the world of time. Okay, so let's take a closer look at this now. because right here we're exposing one of the hidden secrets identified by the critical path method, and that is that the timing is the result of the sequence when combined with the durations of the activities. So here we have our network again, A to F, and this time we put the durations on the network. Now the network shows the sequence, and as soon as we add the durations, the timing is going to become evident, and that happens with the forward pass. And there we have it. The forward pass provides us all the information for the bars to appear on early start. And then when we do the reverse pass, all the information becomes evident for the floats and the criticality and the critical path. None of this would we have if we did not have the sequence and the network. So in conclusion, the timing is the result of the network with the durations on the activities. The critical path method was designed specifically to enable us to use computers. Microsoft Project was built on the critical path method. So now that we understand the critical path method, we will be able to enlist the true power of Microsoft Project. So we open our Microsoft Project file in the network view, and we start at our beginning milestone. In fact, we do exactly what we did in the practical exercises we've done so far. So we start at the beginning with our start milestone, and our first activity is activity A. So we put activity A there. Having done that, if we double click on that, we can put in the name, which is A, and the duration, which is 1, and hit enter. Now, once A is complete, we can do activities B and activities C. So let us put that information in there. This is B, and B has a duration of 6, and this is C, and C has a duration of 3. So we put that information in. Now activity D, remember, can start immediately after activity A. So we put activity D in over here. Double click on that, and we'll make it activity D, and it has a duration of 1. Now, once D is finished, we can do activity E. So we put activity E over there, open it up, make it E, and it has a duration of 2. Now, as soon as B and C are both finished, we can start activity F. So we put F over there, we connect it up to both B and C, and call it F, and it has a duration of 2. Now, once F and E are both complete, right, we can go to the end. So we'll put our end over here, and call it end, and it is a milestone, so it has no duration, and it will look like that for end. and we have to have E and F both completed in order to end the project. So there we have activities A, B, C, D, E, and F, and the end all in the network, exactly like we had it in our exercise we did in the lessons before. Now, in the example we did in the exercises before, as soon as we had the durations on the network, the timing information appeared and the bar chart became evident. In other words, our time view became evident. But the problem was that we had to do all the calculations. We had to do the forward pass to find where the bars were, and we had to do the reverse pass to find out where the floats and everything else was. So that's a lot of work, even for 6 activities. And then, of course, as soon as something changes, we'd have to do it again. So the reason critical path methods was designed in the first place was so that we would not have to do all that calculation, because it could be done on a computer. So that's what Microsoft Project was built for. It was built to do the calculations for us. And as soon as we have the activities and the sequence and put the durations in, we should be able to get the computer to do the calculations and provide the timing. So let's have a look and see. So now we go back to our Microsoft Project network, and we realize, okay, so we've built the logic here, we've got the sequence right, we've put the durations in, but if the computer's going to do the calculations, where is the timing? Well, if you look at the top left-hand corner here, we're in the network view. But there are other views. So let's go to the Gantt view, which is the most simple of the timing views. And we click on that button, and what we have is the timing view of the same project. And if looking closely, the critical path is exactly what we got before. The durations on C, D, and E are the same, and they also have the floats put in there as well. Now, not only that, but not only has Microsoft Project calculated all the timing for us, if something changes, it will recalculate the timing. So let's imagine we have a delay on C. It's delayed from 3 hours to 5 hours. So we double click on that. We change the 3. We're going to change to a 5. Click enter. And what happens? It takes milliseconds to recalculate and redraw the timing and the bar chart. Now, this is significant even in a small project like this of 6 activities. But imagine we have a project of 500 to 1,000 activities that are all linked up with conflicts and everything else. As soon as you get involved with something that big, you realize that doing it with Gantt charts is absolutely impossible. But enlisting the power of a computer, it makes it all possible, and that is why the critical path method was developed in 1957, because computers were going to arrive and make this incredible power available to all of us. Of course, Windows-based computers has made it even better, and all of this power is now available on relatively inexpensive software like Microsoft Project. But the timing is the result of the sequence. People often ask me, how do you keep track of so many activities and people with Microsoft Project? There are different teams performing different functions. So the red line over here, starting over here and all the way along, as you can see, this is basically the critical path and critical activities.
But when we look through the rest of the network, we see that there are many other activities that are synchronized and happening in parallel, if you like. And to a certain extent, a lot of these are really crucial, because even though they're not in fact on the critical path, many of them do have very small amounts of float, so they could in fact, if they're delayed, become critical at any time. Now, from time to time, we have different teams of people or different people moving in and out of the critical path, number one. And number two, doing different jobs in parallel in the background. And when we meet up with these teams just before and we want to communicate to them the overall approach of the project, how we see it happening, what their part is in the overall approach, and where they need to synchronize in seamlessly, is the job that is relatively easy to do if we set up correctly.